So once again, welcome to another video. This is our Counting and Probability 13 video. This is the one you should watch for Tuesday, and hopefully you'll like it. This is a little longer section. There's quite a bit in it, and we'll work on that. It'll be kind of fun. So you'll start to see how probability gets even more complicated. So today we're going to talk about the probability of complements, which is typically it's called the not probability. So it's where you look at the opposite of the set that's being talked about. And from set theory, the complement of set A complement right here, is all the elements that are not in set A. And since hopefully you'll remember Venn diagrams, if I drew a universal set and then I drew a set A in the universal set, then the complement would be everything outside of set A. So that would be a complement. Okay? So hopefully you'll remember that from set theory. It'll really help you on some of these problems. So when we're dealing with the probability, a not probability, or the probability of a complement, we need a formula or a definition. And that's what I have written here. The probability that an event will not occur is the probability of the complement of the event, or if you wish, the probability of not the event. Either one of those is correct. And that is going to equal 1 minus the probability of the event. Now, why is it 1 minus the probability of event? Let's talk about this just quickly. First of all, if you have a whole sample space, then the probability of the sample space is just 1. If you have some event in the sample space, any old event, we'll say its probability is P. So the probability of the event is P, so what's the probability of the complement? Well, the probability of the complement, since the complement is everything not in the event E, the probability of the complement has to be everything in the sample space that's not in E. So how do we figure that out from these two numbers? That's why we take 1 minus the probability of the event. And so that's why we did, one of the reasons we did set theory first, so we would have an idea, we could understand what is meant by not E, and why the probability of the whole sample space subtract the probability of the event gives the probability of the complement. And we'll do a few examples here and show how this works. So just so you know, at the bottom of page 641 in your textbook is that formula and its variations. So I'd encourage you to look at that. So here's a real simple example to illustrate the formula. Suppose in set theory, suppose I have a universal set consisting of the numbers 1, 2, 3, 4, 5. And I have set A, which is 1, 2, 3. Well, if I want to find the probability of not A, or the probability of a complement, then one of the things I would have done with set theory is I'd say, well, A complement is the elements 4 and 5. And therefore, the probability of A complement is the number of elements in A complement divided by the number of elements in the universal set. Well, there are 2 elements in A complement, and in the universal set there are 5, so I would have got a probability of 2/5. So what I would like to do is I would like to expand this just a little bit and do this by the formula. So what would be different if I did it by the formula? Well, to do it by the formula, we would say, well, the probability of A complement is always going to equal 1 minus the probability of A. And what this does is this prevents us from having to actually find A complement in a situation. We just use our set A. So it's 1 minus, well, what's the probability of A? Well, it's the number of elements in set A over the number of elements in the universal set, which is 1 minus 3/5. And 1 minus 3/5 is 5/5 minus 3/5, or just 2/5. So by using the formula, we can bypass actually finding the A complement. It's not necessarily any shorter, but in doing some of the problems that we're going to do today, you will see how you can quickly figure these things out. So let's look at a couple of problems in your text. So suppose we have a 52 card deck. There are 3 probabilities I want you to find here. The first one is the probability of not getting a queen. The second one is the probability of not getting a club. And the last one is the probability of not getting a picture card. So I'm going to pause the video. You should pause it as well. And once you figure out each of those, using our formula, 1 minus the probability of the event, or the probability of A, to find the probability of a complement. Okay, once you do that. So I hope you did each of these, and let's work through them. So what about the probability of not a queen? Well, in every deck of cards, I know there are 4 queens. So the probability of getting a queen is 4 out of 52. So the probability of not getting a queen is 1 minus 4 out of 52, which is 48 out of 52, which as a decimal is going to be about 92% or 0.92. So what about clubs? Well, I know that there are 13 clubs in the deck. Since there are 13 clubs, the probability of getting a club is 13 out of 52. So the probability of not getting a club is 1 minus 13 out of 52, which is 39 out of 52, or about 75%. Okay, how about picture cards? Well, the picture cards are Jack, Queen, King, and there are 3 in each suit, so there are 12 picture cards total. Therefore, the probability of getting a picture card is 12 out of 52, and the probability of not getting a picture card is 1 minus 12 over 52, or 40 out of 52, and that as a decimal is approximately 77%. Okay, so if you got those 3 right, you're pretty much ready for this assignment. Let me talk about one other type of problem. So the last type of problem that you're going to be doing on this assignment will have you using like a graph. For instance, you might see a circle graph. Wow, that's probably the best circle I've ever drawn freehand. I can actually do it in a really clever way. On this, I can do a circle like that and draw it like that. That's even cooler. So I think we'll use that instead. It's more fun to have interesting things to use once in a while. So we'll use my little circle down here. Well, what we want to do is we'd like to take this circle, and suppose we had a pie chart, looks something like this, and we had different pieces of pie. And what I would like to do, suppose they were labeled, you know, this was 20-year-olds, 30-year-olds, 40-year-olds, 50-year-olds, and this was 10-year-olds. And what we were doing is these represented the percentages of people who collected comic books or something like that. And suppose I asked you to find the probability of somebody who is not a 10-year teenagers collecting comic books, so not the 10-year-old group. Okay? And you want to find that probability. Well, how would you do that? Well, what you would do is, this is, say, 1/4 of the circle, because this is 90 degrees, so it's 1/4 of the circle. So the probability of not being a 10-year-old or a teenager collecting comic books would be 1 minus the probability of being in the 10-year-old group or the teenager group. And that, since that probability is 25%, it'd just be 1 minus 25%. So this is very typical. What you can do with graphs is you'll have certain types of graphs, and you want to grab the percentage from the graph for the category, and then define not the category, you do 1 minus that percentage. So it's very similar to what we're doing with the card hands, but you'll be using a graph. Okay, that's all. I hope you enjoyed this video and the really good circle I drew. Alright, we'll talk to you later. Bye.